Welcomes to today's GATE lecture. So, before that, I will introduce myself. I am Shravanthi, Assistant Professor from Department of Artificial Intelligence and Data Science. Today's topic is discussion on supervised learning. From that, we will discuss on regression analysis algorithm. Regression analysis algorithms. So, in this content, we will see based on introduction about supervised learning, regression analysis algorithms, simple linear regression, multiple linear regression, and we will solve some of the GATE questions. We will solve some of the GATE questions. So first, supervised learning. What is supervised learning? So before that, machine learning classified the three algorithms. Machine learning classified into three algorithms. One is supervised learning, unsupervised learning, and then reinforcement learning. From that, we will see supervised learning. Supervised learning is like learning with a teacher. Model is trained on the labeled data set. Unsupervised learning, it is generally without labeled data, it will learn. For example, it will find out the similar data based on the hidden structure of the data, similar patterns, and the behavior. Reinforcement learning will learn from the agent. So it will have an agent, that agent will interact with the environment and it will learn based on the action taken place. So if it is a positive means if it is a right action, it will have a right positive feedback. If it takes positive, if it takes good decision, it will have a positive feedback or positive reward. If it takes a wrong decision, it will have penalty. So it is based on trial and error model. So as we have discussed, supervised learning will train the data model based on the labeled data. So it based on the labeled data, it will predict the output. So labeled data means some input data is already tagged with the correct output. So aim of supervised learning algorithm is to find a mapping function to map the input variable with the output variable. So here input variable is x, output variable is y. So it will map the input variable with the output variable with the function f of x. So in this diagram, it represents we have a labeled data. So machine will discriminate the data based on their labels. So here we will have four types of structures. One is rectangle, other one is circle, triangle, and hexagon. So based on the labels, the model will discriminate the data and then it will predict from the data. So we will have a trained data set. From the trained data set, model will train, and then after that the model will get the test data. From that it will predict whether input data is triangle means it will predict it is triangle. If it is a hexagon means it will predict this is hexagon. So in supervised learning, we will have two basic models. One is regression model, other one is classification model. Regression model is nothing but it will predict the output based on the past input data. So it will, the regression is nothing but it will predict the output based on the previous history, based on the past history. So it is continuous number. The data will be in continuous data or real numbers. Classification is nothing but it will make the decision by classifying them into different categories, which is nothing but either yes or no, true or false, or it is yes or no, true or false, whether it is other categorical values. So the values, the output values here is discrete values or categorical values. So here we have two examples. So we are going to predict the temperature for tomorrow. So here regression will analyze the past input data and then it will predict the data for the tomorrow's temperature. So here the output is 84, which means it will analyze the past history data. From that it will map the output data. So here the output is real numbers. So in classification, based on the past data, it will have the categorical values. Okay, whether tomorrow cold or hot. So here it will have a categorical values or discrete values. So regression algorithms we will see even more deeper. So here it finds the relationship between the input variable and the output variable. So this model is completely used for the prediction of continuous and real variables. So we have some real-time examples, weather forecasting, market trends, temperature, age, salary, so and so on, house price prediction. So in these examples we will use regression algorithms. Regression, we have some more regression algorithms: linear regression, logistic regression, support vector regression, decision tree regression, and random forest regression. In this topic we will see linear regression. So before going into linear regression, we will see a small difference between regression and classification. So regression attempts to predict a value for an input based on the past data. So the output here is real numbers or continuous numbers. Here classification, it will predict the data by classifying them into different categories. So here the output might be either discrete values or categorical values. So it is based on the classification problem. So example is, what is the temperature, predicted temperature for the tomorrow. Here whether that particular patient will have a cancer or not, yes or no. So in this lecture we will see linear regression, simple linear regression and multiple linear regression. So as we have already seen, regression is nothing but maps the input data with the output data. So here of course regression will always depends upon the input variable. So based on the input variable it will predict the output variable. So always there is a relationship between input variable and the output variable. Yes, there is a relationship between input variable and the output variable. So simple words we can say it is a statistical technique that helps us understand and quantify the relationship between two variables. So here we will always use a line equation, y is equals to beta naught plus beta 1 into x. So here slope is nothing but beta 1, intercept is beta naught. So as we have already known, so beta 1 formula, or we can say m is equals to n number of data summation x and y. X is input variable, y is output variable. So x is independent variable, y always depends on x. If x varies, y also varies. So summation xy minus summation x into summation y divided by n summation x square minus summation x the whole square. Intercepts formula b naught or c is nothing but y minus beta 1 x. So this is a simple concept of linear regression. From that we will solve one real time example. Here we have a data set. In that data set we will have the students score. So based on the hours of watching TV during weekends, this we can predict that particular student score. So 0, 96 up to we will have some values. So from this we going to find the equation of the regression line, and then using that equation we will expect the test score for a student who watches 9 hours of TV. So obviously for that we should develop a model regression line. For that we need some more data. From the input data and already predicted past output data, we are going to predict the values. So we need some more data to solve the problem. So summation y. So first, before that we have to compute xy, x square and y square. So based on these values, with these values we are going to compute intercept and slope. So here slope formula we have already seen. So we will substitute those values into this formula. So here n is nothing but 12 because we are having 12 data set. So 12 into summation xy. So summation xy, we have to compute xy and then we have to make summation of all the data. So summation xy is equals to 3724 minus summation x. So summation x is 54, summation y is 908 divided by n is 12, summation x square. So you have to add all these data. So 332 minus summation x the whole square. So 54 the whole square. So if you compute these values, we will get the approximate value minus 4.067. So we found out the slope. Now we have to find out the intercept. Beta naught is equals to y minus beta 1 x. So here y bar, or we can say y bar minus mx bar. So here y value is 908 divided by the data's total number of data set 12 minus beta 1 value. Approximate value is minus 4.067 and then x by total number of data set, which is nothing but 54 divided by, which means summation x divided by total number of data set. So 54 divided by 12. If we compute these values, we will get approximate value of intercept is 93.97. So from this we will get the line equation. So y bar is equals to, either we can put 93.97 minus 4.07x, otherwise minus 4.07x plus 93.97. So our problem is we have to find out the test score of the student who watches the 9 hours of TV. So here we have to apply input data here so that we can predict the y data. So here input is 9. If we substitute 9 here, we will predict the output 57.34. So a student who watches 9 hours of TV over the weekend, we can expect, it might not be correct also. So we can predict that student may get 57.34. This is simple regression. So here simple linear regression, we have one independent variable and one output variable. In multiple linear regression, instead of depending on one input variable, it will depends on multiple independent variables. So it involves multiple predicators or independent variables to predict the one dependent variable. Extension of linear regression problem. So here instead of one independent variable, how many independent variables we have? We have to make that many coefficients and independent variables. So how many independent variables we are having? We have to make, or we have to make the line equation based on that. So y is equals to a naught is intercept plus a1 x1. This is the coefficient for this independent variable x1. a2 is the coefficient for the independent variable x2. If you are having n number of independent variables, so it will goes up to an xn plus epsilon. It is nothing but the error. So we will solve one example. We will solve one example based on multiple linear regression. So here in this table we have two independent variables x1 and x2 and one output variable y. So here we are going to predict y value based on x1 value and x2 value. We have to use matrix approach for finding multiple regression. So before going into solving the problem, first we have to see what is x and what is y. So here x is, here we have two independent variables. So second column represents x1 value, third column represents x2 value, first column is nothing but bias value. So we have to make 1 1 1 1. So if you have only 3 datas, you have to get only, so you have to write the matrix only for 3 by 3. So here we are having 4 data, so 4 by 3 or depends upon how many independent variables we are having. So matrix size also will grow accordingly. So y is 1 6 8 12. So the coefficient of the multiple regression equation is given as a naught is intercept, a1 is for x1, a2 is for x2. So the formula is, to find out the coefficient is x a bar is equals to x transpose x, the whole inverse, into x transpose, the whole thing will be multiplied by y. So first we have to find out x transpose x. So x value will be transposed into 4 by 3 into 3 by 4. So rows will become column will become row. Into x we have to multiply and we will get the result of xt into x. Then we have to make a inverse of it. So by using scientific calculator you can find out the xt x inverse. So after after applying the inverse on xtx, you have to multiply with the same, we have to multiply the same with the x transpose. So after that we will get some other matrix. The whole thing will be again multiplied into y. So after multiply the matrix with the y matrix, you will get the coefficient of a1 and a2. So a naught is, which is nothing but intercept minus 1.69, a1 and a2 coefficients for x1 and x2. So here the line equation, y is equals to a naught, just apply the simplified value, minus 169 plus a1 is 3.48 and a2 is minus 0.05. So hence the constructed model is, here y is equals to minus 1.69 plus 3.48 into x1 minus 0.05 into x2. So from this we can apply the independent variables value to predict the output variable y. So here we will solve some gate questions. Here given data, this question belongs to 2025 set 1. This is NAT type. So here we have to find out the answer. So here we have a given data set -1, so here we have a data set -1, 1, 2, -5, 3, 5 of the form x, y. So we have to fit a model with the equation y is equals to wx using linear least squares regression. So we have to find out the optimal value of w is. So here we have a model y is equals to wx. So to find out this, we have a formula w is equals to summation I xi yi divided by summation I xi square, because we don't have intercept here. Because there is no intercept given in the question. So we have a formula. If we don't have an intercept, we have a formula. So using this formula, we are going to compute the optimal value for w. So here x is, we have 3 data set. So x1 is -1, y1 is +1. So here we have to find out first xy, x1, y1 and then x1 square. So here x1 is -1, y1 is 1. So here x1, y1 is -1. x1 square is 1. So here we have x1, y1 is -1, x1 square is 1. Next data is x2 is 2, y2 is -5. So if we compute this, x2, y2 is -10, x2 square is 4, and we have one more data 3, 5. So here we can name it as x3, y3. So x3 is 3, y3 is 5. So x3, y3 is 15, x3 square is 9. So based on these values, we are going to compute summation I xi yi divided by summation I xi square. So xi yi we have -1, and then x2 y2 is -10, x3 y3 is +15 divided by xi square is 1 plus x2 square is 4 plus x3 square is 9. So if we simplify this, we will get 4 by 14. So we will get approximate value of So we will get the approximate value of 0.285. So the answer will be 0.285 to 0.287. They have already mentioned we have to round up to 3 decimal values. Next question is, this question will be asked in, this question was asked in 2024 set 1. This is MCQ type. We have to get the correct choice from this 4 choices. So here column 1 is principal component analysis, we have to match the correct answer from column 2. So principal component analysis, definitely it is used for dimensionality reduction. So P matches with the second option from the column 2. Next, naive-Bayes classification. Naive-Bayes classification models the joint distribution P of x comma y and then derives P of y given x. So this is obviously generative model. So Q matches with third choice. Logistic regression directly derives P of y given x. So this is obviously belongs to discriminative model. So it matches with the first option from the column 2. So obviously the third option is correct. P belongs to second one, Q belongs to third one, and R belongs to first choice from the column 2. Some more, we will see some more practice questions from the topic regression model. If we fit a regression line y is equals to wx plus b, and then the correlation coefficient between x and y is exactly 1, then what is the correct choice? Here correlation is 1. This means perfectly it's a linear relationship, which means regression line passes through all the points. So second option is correct. Second question is, company wants to predict the salary of employees based on years of experience. Which model is appropriate initially? Obviously, if you want to predict the salary based on the employees' years of experience, definitely it's a linear regression, because we are going to predict the salary of an employee based on the past years of the experience. Logistic regression will help you to make the decision based on the experience and whether we are going to give the promotion or not. Here, for giving the salary or finding out the salary increment, it is completely based on the linear regression. Decision trees, it is a flow chart like structure. It will tries to makes the decision based on the flow chart. Naive Bayes, it will completely feature oriented. It is highly correlated with the features. Based on the features, whether we are going to predict that is apple or not. So it will whether it find out the color of the apple and what is the shape of the apple, and whether the taste is sweet or sour or spicy. Based on that, so it correlates with the other features. It will find out it will predict the output. So obviously here the question is, we have to predict the salary of the employee based on years of experience. Obviously, with the help of linear regression, we can predict the salary. Last question is, a bank uses regression to predict loan default risk, yes or no? Why is linear regression not suitable? Obviously, as we have already seen, linear regression cannot handle categorical values. So obviously for this problem, we have to choose logistic regression, because it cannot handle categorical target values. Thank you. We will meet on next GATE lecture.